Beyond just splitting up the cable forces, how we analyze these forces will depend on the structural system. If you remember from the basic course regarding friction over the tower saddles and walkway humps, we take the more conservative option to analyze our forces. For cable forces, the more conservative option is zero friction, so all of the force is transferred into the backstay cables. For our anchor analysis, it is conservative to assume there is friction over the backstay, but as little as possible, so that the majority of the force is transferred into the anchor. For our tower, tier, and foundation analyses, it is most conservative to assume significant friction over the backstay, so that a larger portion of the force is transferred into our tower, tier, and foundation components. Here we will start with cable analysis. While it is important to eliminate the assumption that all cables have the same backstay angle in order to set up our future calculations, do you think that splitting the cable forces up this way will change our cable capacity? The answer is no. We still need to design to the maximum force in a single cable, which does not change, but it will affect our other analyses down the road because it changes the total force transferred into the anchor. Instead of 4 times handrail forces, or for example, a 2 handrail, 2 walkway cable bridge, it's now 2 handrail and 2 walkway, or 3 walkway or 4 walkway cable forces on the anchor. And another assumption that we make is that the force is distributed by area. Because it is all the same cable material with the same stiffness, we can use area to distribute force. A good example is equation 4.1.24 in the bridge binder. Almost 100% of the time we'll be using the same cables for the walkway and handrail, but in the rare case that there are different cable sizes, it is good to use area to split how much force will flow into each cable just in case you do need to change this. And I've written this equation down below for you.